There's a FRAC article from like, I don't know, 10 years ago that talks about how to, if you control iOS, you can configure essentially the same sort of wiretap where you set up a tunnel, an IP tunnel from the router to some device out on the internet, and you route a particular traffic set through this tunnel, then back, and then out. And so you can set up something like that. It's extremely cumbersome. The person that you're targeting might notice it. This is a single UDP packet. It's a hell of a lot easier to use. And so the fact that it's easier to use makes it less expensive to perform this attack, essentially, and so it becomes more attractive. So I work in X-Force research. We make intrusion prevention systems, and we spend a lot of time looking at security vulnerabilities and trying to think about which security vulnerabilities are more likely to get exploited than other ones. And we came up with this sort of like simple way of talking about the process that we go through, where we consider the economic prospect that a vulnerability represents to an attacker. And so I've got this chart here, and on one axis, I chart the opportunity that a vulnerability represents, like how many systems out there are affected, and what kind of data do they have on them. On the other axis, I chart how much it costs the bad guy to exploit that vulnerability. Does the vulnerability fit into a business model that attackers are already running, or are they going to have to come up with a bunch of new tools and techniques in order to really exploit it and make money with it? So if you think about this, the fact that we've created this infrastructure that makes it really easy to do this, what you end up doing is moving this attack to the right side of this chart. Basically, you're making it less and less expensive to perform the attack, and the consequence is that it becomes more attractive. Most of the vulnerabilities that X-Force gets really spun up about are the ones in this top quadrant that represent a big opportunity and are real cheap to exploit. Anything that you do that makes things cheaper makes them more likely to happen in practice. There's another kind of access list besides these infrastructure access control lists that you can configure on a Cisco router, and it turns out that it has a big impact on the security implications of this interface. But unfortunately, it's not, at least originally when I looked at this, it was not documented in the SNMPV 3 hardening guide or the configuration guides for Lawful Intercept, so I'm pretty sure no one actually does this. But you should if you actually have to deploy this stuff in practice. You can specify an access control list for an SNMPv3 user. So that user can only come from a specific source address. And again, the interception request could be spoofed. So in and of itself, this does not solve all your security problems, but coupled with other things, it can. It may be difficult for an attacker to figure out the IP address of your mediation device. And the other thing is that this actually generates an audit trail. Once you configure this access control list, if you send a packet to the router using that username from a different source address, an authentication failure trap will be generated. So, that's a strange result in my mind, but it can help you identify when things that are suspicious are going on. So this is a good thing to use, but I don't know if a lot of people are actually using it. Another good thing to use is encryption. And I know for a fact that a lot of people are not using encryption with this system. You don't have to have encryption to have the Lawful Intercept feature. And the documentation says, although encryption is not necessary, we recommend it. And I know that they do. Cisco really wants you to use encryption with this, but sometimes you can't afford the encryption version of iOS on your router. And so there's a couple different kinds of encryption that you can use in this context. One is SNMPv3 encryption, and it's a good thing to use because it makes the attack a little bit harder, but it doesn't protect the privacy of the wiretap coming back out. What a lot of people do if they're using encryption is they set up an IPsec tunnel from the mediation device to the router. And that's actually mentioned in the internet draft for the TAPMIB. That's how they meant you to do this. But the problem is, again, that IPsec tunnels are disconnected from the actual Lawful Intercept or the SNMPv3 system. So imagine that there's an IPsec tunnel configured in this case between the mediation device and the edge router. I'm sending my attack from a different source. So when the router receives my attack packet, it's not going to expect it to be encrypted. So the fact that your tunnel is there does not prevent me from accessing the interface without authorization. When my output stream goes out, it's not going to the mediation device. It's going to a different destination on the internet. So again, the IPsec tunnel is only going to encrypt traffic if it's headed for the mediation device, and my output traffic is not. So even if you did go to the trouble of configuring IPsec, it may not necessarily protect you from this attack. Only if you couple IPsec with that user group access list that I mentioned before are you really secure against unauthorized use of this interface. And I don't think a lot of people are doing that in practice. So this is one of the questions. It's like, what do I think people are doing in the real world? I think they're using that infrastructure access control list, and hopefully some people are probably still vulnerable to that authentication vulnerability. Some people are not using encryption, and most people are not using that group access control list. So the consequence is that these systems can be attacked in the real world, and that this attack scenario is realistic in a lot of places. So let me shift gears here and talk about what should be done to address these problems. So there are different layers at which you can address security issues in an internet protocol. You can change the design, you can fix the implementation, or you can just deploy it right. I have some recommendations for proper deployment. I'm not going to bore you with them. As I said before, you can configure this in such a way that it is pretty secure against this attack. I just don't think that a lot of people do that in practice. But there's a couple problems with this. The first is that even if you do this, even if you configure it securely, you still don't have an audit trail. So you still can't investigate misuse of the system by people who are authorized to use it. There's also no way for me as a user to know whether or not my ISP has deployed this correctly. And again, I assume that a lot of ISPs have not. So if you made changes to the design of the protocols, it would make the system harder to attack regardless of how well it was deployed. I have a bunch of recommendations for that. For SNMPV 3, I think that we should get rid of those helpful authentication errors that tell you whether the username or the password was bad. We should send traps and informs with any authentication failure occurs, so the network managers will know when someone's trying to crack passwords. We should also make the engine values more difficult to predict and share. So I would love to be able to do these things, but unfortunately the working group for SNMP is closed. So the process of actually getting the IETF to update the standard to include these changes is this Byzantine bureaucratic discussion that would take several years. So it's not going to happen. These things are all really easy to implement in practice. If you did this to your SNMP implementation, you wouldn't have to have a flag day or anything. You could just deploy it and it would be fine. But unfortunately, that's not going to happen. I also have some recommendations for Lawful Intercept. The most important one is that notification control should be moved into the router configuration so that there's an audit trail for every single wiretap that takes place. Now, one of the reasons for the architecture that exists here, where the audit trail is in the mediation device and not in the router, is that they don't want the people that run the network to know when the police are wiretapping somebody, because they're not necessarily authorized to know that. So if they could go in the router and configure any destination to receive traps whenever the wiretapping system is used, they would know when wiretaps are taking place, and they could call their friend and say, hey, they're wiretapping again. That's why they wanted the Lawful Intercept administration people to control the notification so that the router administrators wouldn't be able to find out what was going on. So what I suggest is you actually need to have agreement between the people who are operating the wiretaps and the people who are operating the network. So when you configure the router, you can configure a bunch of different possible destination addresses for traps. And you enforce that when a wiretap is provisioned, they must specify one of those different destination addresses. If they don't, then no wiretap happens. And this allows you to have different law enforcement organizations that have different security policies using the same infrastructure and the reporting, and they can all control their own reporting so that each one doesn't find out about the other's activities. Again, I don't think that change is going to happen. This design, as it exists, complies with government requirements. And I put that in quotation marks because I don't know which government and I don't know what requirement. Someone mentioned the ETSI standards to me, and I went through the ETSI standards and tried to find a place where they require that you have a way to turn the audit trail off, and I didn't find it. So I don't think it's in there. I don't know where it is, but we see it, again, in totally different lawful intercept systems designed by different people in very different ways. And so there's some fundamental origin of this decision. But the other thing is that network providers are not demanding it. So I want to talk about this. I want to talk about this issue a little bit more, the design, implementation, and deployment. With IETF protocols, you have these protocol designers that design an RFC standard, and then you have these software vendors that actually implement it, right? They make the software that implements the RFC. And then you have these network operators that take that software and they actually run it on the network so you can use it. And then you have customers who actually use that system. In this case, the customer is law enforcement. They're the people who actually access this lawful intercept system, and they're the people who are setting the requirements for how it should work. You're not the customer. What this is, so in economics, this is called a negative externality. And let me give you a more simple example. Let's say you are in Montana and you're making widgets. And your widgets are very popular. Lots of people like to buy them, and you have this great business. But you're also polluting. And your pollution, because of the wind, doesn't blow into Montana. And so the people in Montana who are buying your widgets are not affected by it. It blows into another state. And those people don't buy your widgets. They don't benefit from the product that you're making in any way. And they can't influence your plant operations by choosing not to buy your product. And so the consequence is that there's this economic transaction going on between your plant and the people buying your widgets that has a negative impact on a third party that isn't actually part of the economic transaction and can't affect it. It's a market failure. And it's called a negative externality. And it's often a place where regulation is used, where the government comes in and they say, okay, your customers aren't going to stop buying your product because of this pollution, so we're going to require you to not pollute as much because the interests of this third party are important. Negative externalities can exist in protocol designs. A good example, I guess, is traffic amplification vulnerabilities. So like RTP, you can send a single packet, a single SIP packet, and get an RTP stream directed at a destination address of your choice, right? So you can send this one little packet and get a whole bunch of data to go to any destination on the internet that you want. It's supposed to come back to you, right? It's supposed to be a transaction between you and the SIP server, but you can target someone else as the destination, and as a consequence of that, that third party is negatively impacted, and they have no way within the context of this protocol to turn that stream off. They can't tell you to stop. Negative externalities in protocol design, I believe, we can have a positive impact by addressing them in the design, as opposed to simply pushing the way we address this down to the development level. And it goes back to this model. The protocol designers want to provide as much functionality to the vendors as they can, because that's who they serve. And the vendors want to provide as much functionality to the network operators as they can. But in fact, in some of these cases, if the protocol designers stop and decide to constrain their functionality a little bit, they will have a positive impact on the security of the actual software that gets deployed in the end. So the next question I want to talk about is what's going to happen in the future with wiretapping infrastructure, and I think this is probably the most interesting part of the talk. So illegal wiretapping used to be really easy. You used to be able to go out to a telco junction box with a couple of alligator clips and hook up and listen to somebody's phone call. You could get a frequency scanner and listen to people's cellular phone calls or their cordless calls really easily. Over time, it has been getting harder. Wireless systems are maybe more likely to be spread spectrum today. Cell phones have link layer encryption. A lot of the network traffic that's actually going over the physical infrastructure it uses protocols like DSL that are not as easy to decode. You can't just like hook up a little Radio Shack device and listen in. So it's becoming more difficult to do. But I don't know if we're going to achieve this ideal result where we have perfect end-to-end encryption. People don't tend to use end-to-end encryption systems that often because the actual process of authenticating them is too cumbersome. Where encryption seems to have really taken hold is when it's built into the link layer. And it's invisible to the user. Everybody uses encryption on their cell phones, but they're not aware of it. It's not something that they have to bother authenticating. So if you want to reduce the amount of illegal wiretapping that happens, doing work on making link layer protocols more likely to be encrypted is going to have a positive impact on that. There are still a bunch of link layer protocols that we use that do not have any encryption in them. And there are a lot of assumptions that people make about that.